Okay, good morning. So we continue the lesson to the next chapter. That's actually an important technical chapter, so you have to listen very carefully. So if I want to, so the topic is the topic of logarithms. If I want to motivate you, so if we have an equation of this form, for example, x to the power of 3 is equal to 8, if I ask you what x is, probably you can immediately answer that x is equal to 2, yes? But if I write this one equals to 7, and I ask you the same question, then what is the answer then? Third root of 7. Yes, so that is this notion of the third root is actually referring to the number whose third power is 7. Okay? And then if I ask you what is the third root of 7, you just tell me that is the number whose third power is 7. How do we know such a number exists? That is a little bit harder question to answer, but mathematicians had already answered that question, and the answer is that yes, there is a unique number whose third power is 7, so we are allowed to give it a name, and that number is unique, so we can call it the third root of 7 and write a notation for that, yes? This you are more or less familiar. But now let me change, and I want to put this x on top. So here you see the unknown is in the base, and then the exponent is known. But let me change the numbers, yes? For example, I can write 2 to the power of x is equal to 8. And then I can ask you what x is, then you can immediately answer again, yes? So you would say that x is 3. But then, if I ask you the same question for 7, give me a number so that 2 to the power x becomes 7. At this level, you might think that this is the case that such a number does not exist in the first place, yes? But again, mathematicians have shown that this is the case, and this number has a particular name. That number is called the logarithm of 7, whose base is 2. Yes, that's a fancy way of writing this number. Yes? And then let me just immediately mention, for some reason, this is the first time I see, they write LG for logarithm in Swedish books. And then I haven't seen even once that they put 2 here. I don't know, in your book they have put 2 here. So I don't know why they have written it in that way. Probably there is a logic for that. But that is very strange. So I will use this symbol. So if you want to read the book, remember, if you see this, this is what I write in this form. Okay? Okay, so you might ask me, what is logarithm of 7 in the base 2? What you need to understand, it's just a number. Okay? Whose, when I put it here, 2 to that power becomes 7. That's exactly the same question. If I insist to ask you what is the third root of 7, you really cannot answer unless you tell me that this is the number whose third power is 7. But you can ask me what is the approximate value of third root of 7. That is a reasonable question, yes? So even though we don't know the exact value, you might ask what is the approximate value. For example, you can ask, can you tell me 2 numbers so that this number lies between them? So what is that number? What are those numbers?
1 and 2.
So yes, because you say that if I have 1 to power 3, it becomes 1. And after 1, if I write 2 to power 3, it becomes 8. But 7 is somewhere between 1 and 8. So the third root of 7 should be somewhere between 1 and 2. Yes? Because I say that 7 is between 1 and 8. But this means that the third root of 7 is between 2 and 1. Of course, might be you need better precision. Then you have to have more advanced tools in your hand to be able to approximate it even better and better. But at least you have a rough idea about the size of this number. Yes? Okay, can you give me a rough idea about the size of this number? What is the size of that number?
Somewhere between 2 and 3.
Somewhere between 2 and 3. Why? Because you calculate 2 to power 2, it becomes 4. And when you go to the next power, it becomes 2 to the power of 3, it becomes 8. We are already, so 4 is below 7. But when I increase 1 unit, I go above 7. So this means that this number that you see here is somewhere between these two powers. Understandable or not? Yes? Yes or no? Okay, so this number that you are looking for, which is named logarithm of 7 in base 2, what we know is somewhere between 2 and 3. Not more than that. Here we don't know more than that. But what this number exactly is, we don't know. But what does this mean? It means that is the unique number, so that when 2 is raised to that power, the answer becomes 7. Is this sentence understandable? If this sentence is understandable, I expect you to answer this question immediately. What is the answer?
Oh, it's 7.
It's 7. Because I just told you, logarithm of 7 in base 2 is representing the number so that when I raise 2 to that power, it becomes 7. What I am doing now, I am really raising it to that power. So according to my definition, it should be 7. Is that understandable? So exactly like this. If I ask you what is the third root of 7, you would say the third root of 7 is a number so that when I raise it to power 3, it becomes 7. Now I ask you, raise it to power 7. What do you expect to get? 7, yes? That's exactly the same scenario, yes? But that was for the base, that is for the exponent. Is that clear?
Yes.
Yes or no? Okay. So now that is at least some kind of motivation. So you see that third signs are good if we want to find an unknown which appears in the base. Logarithms are good for solving equations in which the unknown is on the power, is in the power, yes? So remember this. This is a rule of thumb. Whenever you want to solve a polynomial equation, might be third signs are useful. Whenever you want to solve an equation in which the unknown is in the exponent, might be the logarithm is useful. Is that clear? Okay. And now, let me try to motivate you a little bit more. For example, let us consider a function. Let me write this function f of x. Let me work with 2. 2 to power x. This function is called an exponential function. Yes? What is an exponential function? An exponential function is a function of this type whose base is a constant number and its exponent is a variable. This function, f of x equals to x to power 2, is called a polynomial function. A polynomial function is a function, or a power function. It's better to say a power function. Yes, a power function is a function whose base is variable, but its power is constant. You appreciate the difference between these two. Yes?
Is like, or can you call power functions exponent functions? Or is that just something I've made up myself? Because I think I've heard
No, because
it,
when
but
you say
maybe
power
it's
in mathematics, when you
imaginary.
have this number is called exponent.
Yeah.
Yes?
Yes, so I guess it doesn't really.
This number is called the base. The whole expression is called the power.
Okay.
Yes? So I will call it the power function.
Yeah.
Yeah?
Yeah, it's probably better.
Yeah. So f of x is 2 to the x, an exponential function. Okay, so let me just roughly draw the graph of this function. So if you want to help me to draw the graph of this function, of course, drawing graph of functions will be the lesson of the next course. But here, if you want to have an idea how the graph of 2 to the x looks like, it shouldn't be that hard. So try to find some numbers that you can calculate it simply. For example, if I want to write x here and y here, the best number would be 0. Because if I put 0, I can immediately calculate it. It becomes 2 to the 0, which is 1. Let me choose some numbers, positive numbers. Let me also choose some negative numbers to have an idea what is going on. For example, after 0, let me just choose 1. If I put 1 for x, 2 to the 1 becomes 2. And if I put 2, it becomes 4. Yes? And I can continue. And then you see that this will increase rapidly. If I put 3, it becomes 8. If I put 4, it becomes 16. And it increases rapidly. But let me ask you, if I put -1, what would be the answer then?
1 over 2.
1 over 2, yes? Because it becomes 2 to the -1, but 2 to the -1 is 1 over 2, yes? If I put -2, what will happen?
1 over 4.
1 over 4, agree? And if I put -3, it becomes 1 over 8. Okay, it becomes a smaller and a smaller. But be careful. Even if I am putting negative numbers, the values are still positive, but getting smaller and smaller. So it means that the graph of this function cannot go below the x-axis because the y values are always positive. Yes? So let me just try to get an idea. So if I put 0, the answer is 1. If I put 1, the answer is 2. Yes? And if I put, for example, 2, the answer is 1, 2, 3, and 4. And then you know that it will increase rapidly. So then if I go to the other side, if I put -1, then it becomes half. Yes? That's another point. And if I put -2, it also divides once more. Something like this. And if I just connect them together, of course the idea of connecting, you might say that how do you know that this will go so smoothly? At this level we will not be able to answer these kind of questions, but you have to trust me on that. So it will go like that, and from this direction it will go like this. So what do you expect will happen here? When I go to the right, it increases rapidly. When I go to the left, what is happening? Yes?
It's decreasing rapidly.
It's decreasing and decreasing. So this distance between the graph and the x-axis shrinks. Yes? And then it becomes a smaller and a smaller. Do you think I will ever be able to touch the x-axis?
No,
Why not?
because you can't divide anything by.
We would have to like go to infinity, but we can't.
But infinity is not a number.
It's
you
not a
cannot
number.
stand
You
at
can't
infinity.
go there.
Exactly. So it will continue getting a smaller and a smaller and a smaller.
Yeah. Yes.
And this, by the way, you will study it later. This is called a horizontal asymptote for the function. Okay, we say that this function is getting close to x-axis asymptotically. So that's the terminology, but you don't need to worry about that. So that is somehow a rough idea of the graph of this function. Okay, so let me just write these numbers here. So this is number 1, this is 2, and then I have here, this is 4. So the logarithm and exponential functions are called, they are inverse of each other. They neutralize each other. In which sense? In this way. If I ask you, if I give you 1, the exponential function will give you 2. The idea of the logarithm is the other way around. I give you this number and I ask you what was the x value. Is that understandable? So for example, if I give you 2, what is your answer in that way? 1. If I give you 4, the answer is 2. But if I give you 3, what you have to do? You have to draw this line horizontally. When you intersect, go back vertically, and you get something between 1 and 2. This number is the logarithm of 3 in base 2. Yes? So that is the meaning of logarithm. For example, what is another name for 2 in this method? So you know that 4 goes back to 2. So you can say that on the one hand the answer is 2. On the other hand, according to what we learned just now, you can write logarithm of what? 4 in base 2. But logarithm of 4 in base 2 turns out to be 2 exactly. But logarithm of 3 in base 2 turns out to be a number between 1 and 2. What exactly we don't know. But of course, in higher mathematics, you can calculate it up to any desired accuracy. Yes? That's another problem. Is that clear? Okay, let me ask you one question. I want to hear it from you. If I ask you, what is the logarithm? Let me change the color. So what is the logarithm of 2 in base 2? Using this diagram.
1.
So you start from here, go in this direction, what do you get? 1. So the logarithm of 2 in base 2 is 1. Yes? If I ask you what is the logarithm of 1 in base 2? What is the logarithm of 1 in base 2?
0.
It is 0, yes? Because that number corresponds to that point. Okay, now, do you think that a logarithm can be negative? For example, can you give me a number whose logarithm is negative? Exponential functions cannot be negative because all the graph is above the x-axis, so the y value is always positive. Here, x value can be negative or positive, but the y value is always positive. But now I go to the logarithm. Can you imagine a point whose logarithm is a negative number? Which negative number? I don't care that much.
Yes.
Yes?
You can.
Okay, so what? Give an example.
I mean,
No,
I mean,
because the logarithm to find the value for logarithm we look at the y-axis and find the number which we're searching for.
But the answer to the logarithm is the x value.
yes. So it's 1 over 2.
Wait.
1 over 2.
Is
with
that
base.
understandable or not? Yes, understandable.
Oh, okay, yeah.
So the log of
Yes,
log of 1 over 2 with base 2.
is a negative number. Yes, because for example, if I consider this number here, that is a negative number. That is a positive number, 1/2. But if I want to find its logarithm, I have to go horizontally. If I go horizontally in this direction, I will never ever intersect the graph. So there is no point to go in that direction. So I have to change my direction and go in this way. And then I intersect here and then go back to the x-axis. What do I get? I get -1. Okay? Is that clear? So the answer, the output of a logarithm can be negative. So for example, in this problem, you say logarithm of 1/2 in base 2 is which number? -1. So the output of a logarithm can be negative. But what about the input? Do you expect that I can put a negative input inside the logarithm?
Yes.
Can I put a negative value inside? So if I choose a negative value, if I go horizontally, it doesn't matter in which direction I go, I will never intersect the graph.
Not in this case.
There are no other cases. We will come back to it.
Okay.
I will hear from you. Okay, but at least in this picture,
It's impossible.
you see that the logarithm, if this is -1, if I ask you what is the logarithm of -1 in base 2, if you want to do this process, what do you get for the answer? What do you get? Yes?
Undefined.
Undefined. So nothing, you will get nothing. So you start from here. Do you remember when I gave you these numbers, you start going horizontally, find the intersection and go back vertically. Yes? Now if I give you this number, if you want to do the same thing, you go horizontally, but if you go horizontally, you will never cut this. There are no points that you can give me as an answer. So this is important. The number that I put in a logarithm cannot be negative. Yes? But the output of a logarithm might be negative. Yes? Let me compare it immediately. I will come to you. Let me compare it with this square root function. Can I put a negative number below it?
No.
Can I put a negative number here?
No.
No. So I have to respect to put positive numbers there.
Yes.
But if I respect and put positive numbers there, what do I get? Positive or negative? Always positive. This is different here. You are not allowed to put negative numbers. You are only allowed to put positive numbers. But even if you put positive numbers, sometimes you get negative values. Yes? I'm just trying to compare these two things so that you can remember these things. Yes? So that is a big difference between a square root and logarithm. What is the similarity? We cannot put negative numbers for them. What is the difference? The difference is that if I respect and put positive number here as an input, I will get a positive number as an output. But in logarithm, even if I respect to put positive number, sometimes I get a negative output. So remember, yes? Someone had some questions, yes?
We can't have a negative input for a logarithm. We can have 0 as an input.
Okay, that's a good question. Now someone else answers Sergey. So he's asking, if someone asks you logarithm of 0 in base 2, what will be your answer? Yes?
Isn't that also undefined?
It's also undefined, but it's undefined. If you want a little bit more advanced mathematics, it's undefined again. No doubt about it. Logarithm of 0 in base 2 is undefined. But what do you expect if the number is not exactly 0, but if the number is very, very close to 0? For example, something like this. This one is undefined. But this one is undefined or not? It's defined. But what is the value? What do you expect? Is the value large or the value is small? Ali?
Very big negative number.
Very big negative number. Because when I say very, very small positive number, I am here. And when I go horizontally, I will go to the left, very much to the left, to be able to intersect the graph. So this means that some books write minus infinity, but that's not correct. But if you want more advanced mathematics, you can just simply ignore that. So you can say the logarithm of x in base 2, when x gets close to 0, from the right-hand side is negative infinity. Yes? But forget about this. So, what we learned is that if I ask you logarithm of x in base 2 is a function now I'm asking you, can you tell me the domain of the function? The domain of the function is the possible values that I can put in. What is, yes?
Anything over 0.
Anything over 0. Is 0 included?
No.
No. So you would say that x greater than 0 is the domain of this. Yes? Okay. But one thing, I don't know, in your book they are delaying talking about logarithm in different bases. They have started with logarithm in base 10 and then teach you another base. Okay, but that is not very, I think, instructive. I have started with curve 2 to the x. I could have started with the curve 3 to the x. I could have started with the graph of 4 to the x. So, and then what will happen, this will affect this number that appears in the base. But the ideas are exactly the same. Of course, the numbers are different, but the ideas are the same. Yes? Okay, but now I want to hear from you, Oscar. So you said something about, in this case, it is above. Yes?
Okay.
Is there any other exponential function?
What if you were to write the function f of x equals -2 to the power of x, what would happen then?
No, that's not an exponential function, because that is an exponential function multiplied by a negative
but
sign.
like the -2 in parentheses.
No, that's a good question. How come? Is anyone who wants to answer the question? They are asking,
Well, it'd be
what about this function?
it's like a zigzag.
It's,
Well, it goes from positive to negative to positive to negative.
Ah, yeah.
So what happened?
No, but you're only considering the integers.
Yeah. And
Here, I was a little bit sloppy. I told you that because we do not have enough tool in our hand mathematically to draw the graph completely. So this is why I chose integers so that I could calculate, and then I ask you to trust me on that. That would be the graph.
oh, yeah, det är så.
But if we have this, the problem is more serious.
oh, it's the square root from negative.
Because, for example, what is the value of this function? Yes, if I tell you, for example, x equals to 1, then you say minus 2 to the power of 1 is minus 2, okay. But what happens if I give you 2, then you say it becomes 4. So negative, positive. But between 1 and 2, there are infinitely many
And that
numbers.
becomes a square root.
So, for example, what happens if I give you 1/2?
Yeah.
1 and 1/2.
Yeah, that's the square root.
Or 3/2. Then it becomes problematic again. It's not defined at all. Because then it becomes minus 2 to the power of 3/2. But this means the second root of minus 2 to power 3. Minus 2 to power 3 is minus 8. And it becomes square root of minus 8, which is not defined at all. So this is why, that's by the way a very good question. When I say an exponential function, I mean something like this, but I have to put some restrictions on a. Otherwise, I will face these kinds of problems. And I want to hear from you what restrictions you put
Can't be negative.
on a so that it guarantees I am not in trouble.
Can't be negative.
Yeah, a should be positive. But there is also another one which is not interesting at all.
What?
If I choose a to be, which number? No, when I say greater than 0, I am already excluding 0. But I am not excluding 1 when I say a greater than 1. But the point is that what happens if a is 1? It's not exponential function. Suddenly it becomes 1 to the power of x. But 1 to the power of x is just simply 1. And if I ask you to draw the graph of this one, this becomes a horizontal line. So it's not exponential anymore. So when you say that you have to exponential function, remember, a should be positive and a shouldn't be equal to 1. So that's crucial.
But why can't you say that it's an exponential function? Like, I get that it's also it's quite a boring exponential function, but it like
That is up to you. If you want to call it a boring exponential function, that's not a problem. But mathematicians choose to say that a is not equal to 1. You can say that if a is 1, I am facing exponential function for which everything I need I know. So let us exclude this. That's up to you which one. You can say that, okay, I also consider this as an exponential function,
But like
but a trivial exponential function that I know everything about, that I want to know. So let us exclude it from our, yes.
like by definition, is this not an exponential function, or is like
No, so if you want a technical term, this exponential function is not one-to-one or injective. And if you have a function which is not injective, it is not invertible. So then you cannot talk about logarithm of this function. Yes? So this is a little bit more technical. But you have to trust me on that. Just exclude 1. Because if you have a horizontal line, it's a function, but it's not a one-to-one function. And if you don't have a one-to-one function, you are not allowed to talk about its inverse. But that is why we really will have to exclude 1.
oh okay.
Yes? So that is an exponential function. So from now on, when I talked about an exponential function, you have your variable on top, you have a constant number as a base. But there are some restrictions for that constant number, even if I don't tell it to you. A should be positive, and A shouldn't be equal to 1. Yes or no? Okay. Now, what would be the consequence of this? So, for example, let us consider y equals to 2 to the power of x. Using this graph, I was able to talk about the logarithm in base 2, something here. Now, if I tell you y is 3 to the power of x and draw the graph for you as before, yes, instead of 2 to the power of x, I draw the graph of 3 to the power of x. The graph is more or less similar, but of course with different numbers, yes? And then what you expect, you get logarithm in base 3, yes? And then if I write y equals to a to the power of x, you get logarithm in what? Base a. But remember, this a is now transferred here. But what was the condition for a? The condition for a is that a should be positive and not equal to 1. So that is also crucial. When you have a logarithm, a cannot be negative. A should be positive and a shouldn't be equal to 1. So now, if I want to summarize everything, if you have a log, if you have a number in front, and if you have a number in the base, you need to know a should be positive, a should not be equal to 1. These are the things that we have to respect for the base. And what was the condition that we have to respect for x? Forgot or you remember? What is x? Yeah? Yes?
Not negative.
Not negative is not a good number, because when you say not negative, it means that 0 is possible. But you should say positive. Yes? So x should be positive. So I really want you to remember this from now on. Whenever you see this symbol, implicitly it means a is positive, a is not equal to 1, x is positive. This is important to understand about this symbol, yes?
Even though you can technically find a scenario where x and a can be equal, you know.
Exactly. That symbol is not defined for those cases. Yeah. So what you're asking is that if you're asking logarithm of 1 in base 1, technically it should be 1, but it's undefined. Yeah. Okay, that's a good question, by the way. Okay, so so this I want you to write down somewhere. So what you learned at the end, if you like to understand, that is the way of understanding. If you don't want to understand, that is what you need to know as information. When you have a logarithm of x in base a, x should be positive, a should be positive but not equal to 1. Is that understandable or not? Yes? Okay. Now, can you imagine another scenario for exponential functions? Do you think because if I ask you to draw the graph of 3 to the x, I don't think that's a big difference between the graph of this and the graph of that one. You can test it yourself. But do you think these are the only cases that we have? If whenever I draw an exponential function, I get something like this, do you think?
No.
Yes, Ali?
I've seen in GeoGebra, it can go like this too. When
No, it goes higher, actually. This one, GeoGebra, you mean this?
No, the other way.
The other way around. Yes, so it means that sometimes it goes like this. Yes? But can you tell me, for example, for which case it goes like that?
When a value is less than 1.
A value is less than 1, but on the other hand, it should be positive. So whenever a lies between 0 and 1, you will have this behavior. Let us check that, by the way. So let us check this. Let me, this time, choose 1/2 as your base. So y equals to 1/2 to the power of x. Or if you don't like it, let me write it in this form. 0.5 to the power of x. That's also an exponential function. Is this number acceptable? Yes, because 0.5 is positive and it is not equal to 1. So this is an acceptable exponential function. But let us draw the graph of this one. So I have changed 2 to 0.5 this time. Okay, let us check what happens. If I draw the graph, x and y, I put 0, 0.5 to the 0, again 1. No problems. But if I put 1, it gives me 0.5, which is 1/2. If I put 2, it gives me 0.5 to the power 2, which is 0.25, which is 1/4. Yes? And then if I go to negative values, what happens? It becomes 0.5 to the power of -1. But what is this one? It's 1 over 0.5. But 1 divided by 0.5 is 2. So the answer becomes 2. If I put -2, you can convince yourself that the answer becomes 4. Yes? So what happens? So if I draw the graph, if I put 0, again I get 1. So the graph also passes here. But if I put 1, it becomes 1/2. Here. And if I put 2, it becomes even smaller here. And then I can continue. But if I go to the negative values, if I put -1, it becomes suddenly 2. So that's the point here. And if I put -2, it becomes 3 and 4, for example, here. And then you see that the graph would be something like this. And then this time continues forever. So this behavior is called increasing function. Increasing. So when I go to the right, always I go to the right, that's the convention. By going to the right, the height of the graph becomes higher, becomes bigger and bigger. So that function is increasing. But here, when I go to the right, the height of the graph is actually declining. So this means that the function is called decreasing. Yes? Increasing means when I increase x, y also increases. Decreasing means that even though I am increasing x, but the y value is decreasing. Yes? So these are two types of functions. So do you think, for example, let me ask you some questions here to test your understanding. So let me write these numbers in front of your eyes. Okay, now I ask you some questions. If I ask you the logarithm, by the way, what is the base corresponding to this exponential function? What is the base? 0.5. Yes? And then I ask you what is the logarithm, for example, of 2 in base 0.5. Can you answer? It's -1 because the rule is the same. You go to 2 and you draw a horizontal line so that you intersect your graph and then go back vertically, you get -1. So the answer to the logarithm of 2 in base 0.5 is -1. Yes? And then, for example, if I ask you the logarithm of 1 in base 0.5, what's the answer? 0. Yes? If I ask you the logarithm of 4 in base 0.5, what's the answer? It's -2. If I ask you what is the name for this number, if I have this 3 here, if I go back, and if I ask you to write something in the for the question mark, what is the question mark here? Logarithm of which number? 3 in which base? 0.5. Yes? Okay, so actually this is the only scenarios that you need to know. So you know that I have two types actually of exponential functions. One type is increasing type. When this happens, when the base is larger than 1. I might also have decreasing exponential function. When this happens, when the base is somewhere greater than 0 but smaller than 1. For each case, I have a corresponding logarithm function. Yes? So here, let me ask you again, do you think that I can put negative numbers for these type of logarithms or no? Again, no, because if I go to the negative value and if I draw a horizontal line, I will not have any intersection. So the rules of the numbers that I can put in doesn't change from this type to that type. They are the same. Understandable or not? Yes or no?
Yes.
Okay. Now everything is more or less motivated, but now everything becomes simpler. That's just a lot of information that I gave to you, but now we want to start doing these things systematically, okay? So I want to define what is the meaning of a logarithm, okay? So let me start from here. Might we need the graph? So let me write definition. So I will write here for you let let me choose these letters now. Let B be positive, B not be equal to 1, and let A be positive. Yes? Logarithm of A in base B. I don't know, I'm confusing you or not, because I use A here. It's a standard to write B here because that is the first name of the base, yes?
Yes.
So, but that is, I hope that you are switching immediately in your head. I have given the role of that A to this B here. So B should be positive and not equal to 1, but the number in front should be what? Positive. Yes? Logarithm of A in base B is the unique real number such that B raised to that power becomes A. Yes? So in principle, when I say logarithm of A in base B is a number, I call it x, it means that when I raise B to power x, it becomes A. Yes? I told you that logarithm of A in base B is the unique number so that when B is raised to that power, the answer becomes A. So this is the definition of logarithm. This I really want you to just memorize today. It's not hard. When you say logarithm of A in base B is a number x, it means that when I raise B to this power, the answer becomes x. The answer becomes A. Is that understandable? So this is very, very important, and you see the arrow is double-sided. Sometimes this is given, you need to get rid of logarithm and write it in exponential form. Sometimes there are no logarithms at all. It's an exponential form. You should be able to go back and write it in logarithmic form. So you need to somehow send it to your memory just now, okay? If I have logarithm of A in base B is equal to x, immediately means this lower number to power, so you can remember this way of moving, yes? B to power x becomes A. That's up to you how to memorize, but that's the way, okay? For example, logarithm of 16 in base 4 is equal to 2. If someone asks you why, you should say since 4 to power 2 is 16. Yes? So if you want to see if this equality is true or false, you need to check this number to this number. Is it equal to this number? If the answer is yes, then this is true. If the answer is no, then this is false. Yes? For example, logarithm of 16 in base 2. Can you guess it? Can you guess? This is asking you, give me a number here so that when I raise this to that, it becomes 16. So what's the answer? Yes? 4. So you should write logarithm of 16 in base 2 is 4, since 2 to the power of 4 is 16. Yes? Can you let us ask you this question? A logarithm of 125, I don't know if you can calculate it in your head. Logarithm of 125 in base 5. Yes, that's 3, as you said. Why? Because 5 to the power of 3 is 125. Yes? Let me ask you another question. Logarithm of 1 in base 1 is what?
Undefined.
Undefined. Be careful. Even though you might say 1 is correct, because 1 to power 1 is 1. That's correct. But I told you that for this is extremely important to respect these rules. So here, the base should not be equal to 1. So it's undefined. Be careful. Okay? Let me ask you another question. Can you answer this question? Logarithm of a square root of 2 in base 2. Yes?
No, I was just going to ask, could you please repeat why the 1 was undefined?
No, because when you want to define a logarithm, you have to respect 3 conditions. If that is not respected, even though we have for example, like this. If you write 4 is a number, 0 is also a number. If you write 4 divided by 0, it is not defined. Yes? Even though this is mathematical object, this is a mathematical object, that's also a mathematical object. It doesn't mean that if I have mathematical objects and write them one after the other, it makes sense. I have to respect the rules. The rules that you have to respect for logarithm are threefold. This one, and that. Yes? Okay, what is logarithm of the square root of 2 in base 2?
1 over 2.
1 over 2. Yes? Why? Why is that true? Since, what should I write? Since 2 to this power is square root of 2. Yes? Is that correct? So it's logarithm of square root of 2 in base 2 is 1/2. The reason is that, do you remember, that was a famous formula I told you before. If you have a to power 1 over n, you can write it as the nth root of a. By the way, these formulas are very, very important when it comes to logarithm. Please memorize them. I don't know. So you need to memorize them. So if this goes here, this goes here. Of course, if n is even, a should be non-negative. So if you have forgotten these 2 formulas, and I told you that when I don't write any number here, it means it is 2. If you want, I can also add it here. So these are the things that you really need in this lesson. Is that understandable? Okay. So now can you tell me what is this one? So what is logarithm? I put 2 here, square root of 2 here. What's the answer?
2.
This is 2, yes? If someone asks you why this is 2, you would say since, what happens? This number to this power is this number. Yes? So whenever you want to see if a logarithm is true or false, you translate it into the language of exponents. And if that turns out to be true, you say this is true. If that turns out to be false, you say this is false. Is that clear? Okay. So can you tell me what is this? Logarithm of 0.01, and I put the base 10.
And minus 2. -2.
What is that?
-2.
Anyone else?
Yeah. Okay.
Anyone else? Either confirm or give you a new answer. Yes?
-2.
-2. Yes, that's completely clear. Why is -2? Because 10 to the power of -2 is equal to 1 over 10 to the power of +2. It means 1 over 100. Writing in decimal points, it is 0.01. Okay? Is that clear? Okay. A convention that is very important. Whenever the base is 10, we don't write it. So this is remember. Exactly like here. Whenever this number is 2, we don't write it. And the reason is that because these are more popular. They are happening most of the time. We want to be lazy all the time, so we don't write it down. And logarithms in base 10 are more ubiquitous in mathematics, so we decide not to write it. So, yes?
So if you just write log, it's automatically log with the base of 10?
Base 10. Yeah, so that's what I'm saying. So that's convention. And then there is another convention in your book, which is very strange for me. The logarithm of base 10, they don't write log, they write lg. But please don't follow this. I will also always follow log, okay? So I don't know, that's a strange convention. But lg in the book means log in base 10. Okay? So convention, log means log base 10. So when I write something here, without writing this, I mean that thing in base 10. So that's our convention. So in principle, can you tell me what's the answer to this? What is the log of 100? Just log of 100.
2.
It's 2. Yes? Why? Because this number, which is not written, means it is 10. 10 to power 2 is 100. So when I ask what is log of 100, the answer is simply 2. Okay? Any questions? Okay, let me ask you one more here. So what is the answer to this? Log. Okay, so what is the log? So the problem are not that simple always. By the way, the questions regarding logarithms could be among the hardest questions. Okay, so logarithm of this one I expect you to answer. So logarithm, let us just test some simple ones. 81 in base 3. What's the answer? What is that, everyone?
4.
It's 4. Why? Because 3 to the power of 4 is 81. 3 times 3 is 9, times 3 is 27, times 3 is 81. Yes? So what is the logarithm of 25 in base square root of 5? What's this? Yes? Sergey? No? Yes? 4. That's 4. Why? Because the square root of 5 to the power of 4 means a square root of 5 times the square root of 5 times square root of 5 times square root of 5. Yes? But this one becomes 5. This one becomes 5. Then 5 times 5 is 25. Yes? Okay, let us see how many of you can solve this one. Okay, so that's not hard. Logarithm of 8, but let me write base 4. So you might say that this is one of those cases we cannot calculate exactly. Of course, many of them we have to use our calculator. Okay, so I will start cleaning the board. So let me raise it for you. Oops. logarithm of 8 in base 4. So far, I was relying on your ability to guess. But sometimes it is not easy to guess, even for me myself. So then assume that you cannot guess, but you shouldn't give up. You cannot guess, but you should be able to solve. Okay, so might be you found it a little bit counterintuitive and you cannot guess, no worries. But we want to find it. This I want you to learn. So far, you were able to guess. That's okay. But sometimes the problem is hard, we cannot guess. This is not a hard problem, but at least we are getting to the hard ones. So the logarithm of 8 in base 4, I don't know it. In mathematics, when you don't know something, you usually call it x. Yes? And then you are trying to find x. But then it becomes very simple immediately. Don't you agree with me? Because if the logarithm of 8 in base 4 is x, what can I conclude? Everyone, what can I conclude? 4 to the x is 8. So 4 to the x is 8. For our brain, working with exponents is easier than logarithms, yes? And then, this is 4, but you know that there is a connection between 4 and 8 as powers of 2. So then what you write 2 to the 2, and there is another x on top, but this 8 becomes 2 to the 3. And then what happens, you know the rules. 2 to the 2 to the x becomes 2 to the 2x. On the right hand side you have 2 to the power of 3. And then you really don't need to guess anything. Because 2 to some power is equal to 2 to the power of 3. This cannot happen unless the exponents are the same. Yes? So this means that 2x is 3. And then I was looking for x. So what is x? X is 3 over 2. So this one was not easy to guess, but it is not to calculate at all. Agree with me or not?
Oh, yeah.
Yes or no?
Yes.
Okay. Now, if you don't mind, let us start just fun problems, yes? Okay, so I don't know, if you understood what I said, you should be able to calculate this one for me. It's a hard problem, I want to wait for you, okay? So I will tell you the logarithm of the third root of 16 and then as the base I put 1 over the fourth root of 8. Yes? Okay, so let me write it a little bit bigger. No one probably can guess this. So I am asking you, give me a number so that when I raise this strange number to that power, it becomes another strange number, yes? That's what I'm demanding. Okay, so I want to wait for you to see how many of you can calculate this. So what you need is on the board. So let me raise the board. Might be you need formulas. I don't want you to rely on formula sheet that much. Memorize them. Yeah? Why did I clean that? Okay, I have to write it again here. But please memorize them. You will actually save my life, you know. So this one is a to power 1/2. This one is a to power 1 over n. And this one is a to power m over n. They are really important for this lesson of logarithm everywhere. So I pause recording. It's very important to work with me if you want to learn. So you have to pay attention and try to solve it. I give you 5 minutes. Yes, what's the answer?
Minus 16.
Minus 16? No.
No.
But it was not completely irrelevant, you know. Do you have the answer?
Is minus 1/2?
No. Yes, Oscar?
Is it minus 16 over 9?
Thank you.
Okay.
Yeah. Anyway, I forgot to record this part, but at least it is in the camera now. So you see the solution, but not live solution. Anyway. Any questions? Okay.